Let's see if this is working. Is this working? Okay. There we go. Okay. So let's pick up where we left off. We're going to switch over to the mode where I do the writing. Let's switch over to writing mode. Sorry, just having a difficulty. Boom. Okay, cool. So let's sort of review the things we did last time. So we talked about how statistics is this study of making decisions. You're using information to make decisions. And then we talked about how Wolfram is where you're going to deal with the information. And then we're going to use that to do calculations. And then you're going to have to like make the decisions based upon the calculations that you had. So we talked about some stuff. We talked about like vaccines. You know, you might have to test if it's effective or not. And how, well, you could give it to everybody, but that's not going to be very useful because you want to sort of figure out if it's effective or not before you give it to everybody, right? So we talked about how that's called a sample. You're only giving it to some people. And then we discussed how, like, depending upon the people that you test the vaccine on, you might introduce bias, right? So bias is when the people who are involved in the study influence the outcome. So if you, for instance, I gave this example where it's like, well, let's say you tested a vaccine on people who are like over the age of 80 and who are diabetic. You might see that a lot of them died. It's the fact that they died, that may not be from the fact that your vaccine is ineffective. It might have more to do with the bias introduced from the people that you're working with in your sample. Okay. So we talked about bias, we talked about samples, and then I talked about how, well, the only way to like make sure that this really works out is that you want a random sample of people. You need to take a random group of people. You don't want to like test it on just 80-year-olds with diabetes. You just want to randomly choose people of various ages, various health statuses, and whatnot, and see how it works there. So I think that's like a sort of a quick overview of what we talked about last time. Before we keep going forward, are there any questions about the stuff that we discussed last class before we move forward? We ready to move forward? It's sort of funny when I teach this. I'm going to show you what I see. I just see like a bunch of like, oh wait, let me change over to the what's it called view. Oh, Wolfram? Sure. So Wolfram, let me share my screen. Oops. Okay, let's change the window capture, change to Wolfram. So this is Wolfram. Let me open. I'll do this one. Oh, no, that's not a good one. Let me open a different one. Let's do. I'm trying to find one that like will be useful to deal with. Sort of show you what it is. So here is like some data. I have some data that's from the American, what's it called? It's called the American Community Survey. It comes from the Census Bureau. I don't know how well, let me make it zoom in a little so you can sort of see my screen better. There we go. Okay, and then we zoom. Okay, so this should sort of look like an Excel spreadsheet to you if you've worked with Excel before. So do you see how it says like income right here, and then it says employment, hours worked, race, age, gender, citizen, time to work, language, and whether you're married. So what this is a bunch of information about people. So if you look at the first line, it says 60, or the second line, it says 60,000, not in labor force, 40, white, 68, female, yes, NA, English, no. That means that that's a person who's made $60,000, they're not in the labor force, they worked 40 hours a week, they were white, their age was 68, and they were female. Wolfram is the place where we're going to like have the computer do calculations for us or find information that we need. Does that sort of explain what that is? Like Wolfram is where we're going to do all of that. So you're not gonna, in this class, you're not gonna have to calculate things by hand. We'll have the computer program do it for us. Okay, and I'll teach you how to do all of this. Yeah, I guess let me go quickly find the link again and give it to you since it sounds like you weren't here. 1 second while I... yeah, so I'll just paste the link again into the chat, but yeah, so you gotta go and sign up for it. So let me quickly find that. So yeah, please go make an account there. You have to use your Aloni email address. Otherwise, it's going to cost for you. Okay? No problem. Okay, so let me change my screen. Let's go back to the other one that I had open. Okay, so we're going to keep talking about this today, about these statistics terms. Oh yeah, can you turn that off and take the tea leaf out? Thank you. Okay. So, let me just get my screens ready. So, oops. When you're testing to see if something is effective, this example is going to be, let's see that we want to test whether we're going to test whether tutoring improves math grades. Oh, I forgot to press record. Let me press record. There we go. So we're testing to see if whether tutoring improves math grades. Okay, so what you could do is pay for a bunch of tutors. So pay for tutors and put them in all your classes, and put the tutors in all classes. So let's say at the end of the semester that you notice that their grades are better than last semester. Does this show that the tutoring worked? It was effective in raising grades? What do we think? So like you paid for tutors, they were in all of the math classes. At the end of the semester, you look at the grades, and the grades were better than they had been before. Okay, why do you think that shows that they're effective? Okay, yeah. So you're comparing the before and after of the grades, basically. Okay. Now, you would think that this would work in proving that it's effective. This actually doesn't work, and there's some interesting reasons why. So, the before and the after, I'm assuming you would compare the grades from like fall 2020 statistics with, let's say you did it this semester, compare them with spring 2021 grades, stats grades, or math grades, or whatever. Is this a fair comparison? Like, what is wrong with this comparison, I guess, is the better question. If you compare the grades from fall 2020 with the grades from spring 2021. Like, what's wrong with that comparison? What's wrong with trying to compare the grades from spring to fall? Like, there's something different there. Like, yes, they're all the same. Mm-hmm. Yeah? Yeah, there's actually a lot of different reasons along that vein. So let's talk about the things that have possibly changed. So maybe there are different professors. Maybe they cover different material. There are definitely different students. Yeah, maybe they're different classes. All of this is like super different. So instead of stats, let's just put math. That's not a fair comparison because the people, maybe it just so happens that during fall 2020, like the epidemic wasn't as bad, and let's say the epidemic is really bad this semester. What's going to happen to everybody if like the epidemic gets worse and like people are out of work more and more? Like realistically, what will happen? Okay. So like realistically, what would happen? Like, okay. So realistically, what would happen? Like, you know, if the pandemic gets worse, like how might that affect the outcome of what happens in the course for you? Yeah, exactly. And that's the whole point of this, where if you're comparing one group of people from a particular time period with a completely other different group of people, maybe the grades went up because those people were just more prepared. Or maybe the grades went up because the professors made the class easier. Or maybe the grades went up for a reason other than the tutoring. Okay? Right? So does that sort of make sense? Like, if you compare the grades from fall 2020 with grades in spring 2021, you can't say for certain that it's the tutors that raised the grades. So you can't say for certain the tutors raised the grades. Okay, because there's all these different variables, let's call them, that you can't account for. Just because you know that there were not tutors before and there are tutors now, doesn't mean that you can say that it's the tutors that caused this change in the outcome. Okay, is this idea making sense so far? Like, it looks like you could make the comparison, but it actually is not a good idea to do that. So how do we feel about that idea? Can we get some reactions in the chat? Or okay, cool. So it's making sense to people. Good. Okay, so we're gonna further explore this idea. So if you want to see if tutors are actually the reason, what would you need to do that? So what do we need to do? So what do we need to do to see whether tutoring is effective? Okay, so one of the important things is that you need to run your study at the same time. You can't compare the results from one semester with the results from another semester. Okay, so what you're going to do is you're going to take the people, let's call it your sample, the people who are in the math classes, so the math students. And what you're going to do is break them up into two groups. We call these two groups the control group and the treatment group. Okay. So the difference between these two groups is that the treatment group gets tutoring. The treatment is the thing that you're testing. So if you're testing the effective of tutoring, your treatment is tutoring. The control group does not get the treatment. Okay, and the idea here is that let's just choose some random class. Let's say, you have students in Calculus 1. Taught by Professor Jones. What you're going to do is half of those students will get tutoring, the other half will not. So what is the good thing about doing this? Like, why do you want to have half of his students get tutors and half of the students not get tutors? Like, why might this be a good reason? Like, how is this different than before? Yeah, it's the same subject, it's the same professor. It's notice that the professor's teaching both groups of those students. What's the only thing different about the two groups now? Same material covered, same lectures they all go to. They all meet with Professor Jones. They're all taking the same class. What's the one difference between the two groups now? Exactly. So now, the only difference between them, let's write this down. Now, the only difference, hopefully, is the tutoring. Now, if at the end of the semester you see that the students who were tutored have higher grades, you actually have a pretty good reason to say it was probably the tutoring, because everything else was the same. Okay? And we talked about this last time. How should you choose who gets the treatment group and who gets the control group? Should I put all like the men in the treatment group and all the women in the control group? Yeah, you should do it randomly. Right? We talked about how if you do things randomly, so this is called random assignment. You randomly assign them into the two groups. That way you make sure there's as little bias as possible. Because if you put like all the men in one group and all the females in the other group, the outcome might have more to do with the fact that maybe men don't study as hard as women or vice versa or something like that. Okay, so you need to randomly do this. Okay. Cool. So is the difference between the treatment group and the control group making sense? Any questions about this process and why it's more effective than, say, giving the treatment to everybody and then comparing one time versus another time? Anything we want to ask so far? They actually do this in vaccine trials. So in vaccine trials, what is the treatment? So if you're testing the effectiveness of a vaccine, what happens in the treatment group? Yes. And then what do you do in the control group? Actually, not quite. You give them something, but it's definitely not the vaccine. Yeah, and we're going to talk about that. So, there's this interesting thing, like, so, let's say that you tell someone that you're going to give them opioids. So I tell you, this vial has opioids, like heroin or something. And then you inject it into the... Oh, sorry, my dog. Shh, stop. Okay, but let's say that actually it's just like water or something. Do you know what happens if you tell people that you're going to inject them with drugs and then you inject them, even though there's no drugs in it? Like, what do you think might happen? What will people say about how they're feeling if you tell them you just gave them drugs? Like, this is actually a thing. Yeah, they act like they're high, but more importantly, the placebo effect means that, like, sometimes people will actually feel high. So they will actually, quote unquote, feel the effects of the drugs. It doesn't last that long, and it goes away. Like, it's not like it doesn't. Yeah, it doesn't last that long, and it's not as intense as actually taking drugs. But the thing is, if people are expecting something to happen, they usually feel that, and we call this the placebo effect. So people usually report what they expect. So for instance, if I tell you, hey, you know, I am the best teacher in statistics ever, all my explanations are so good, or someone else tells you that about me, you're more likely to say, oh, the class was very good. But if someone told you, oh, this guy, he's like horrible, like nothing he ever says makes sense, you're more likely to say that as well. Okay, so there's a placebo or priming effect, it's sometimes called. Okay, So it's really important when they're doing trials that you don't know which group you're in. You don't know if you're getting the placebo. You don't know if you're getting the vaccine. So we call that a blind study. So a blind study is when you don't know which group you're in. The whole point of this is that you don't want your study to suffer from the placebo effect. You don't want people, like sometimes if you tell people that you're giving them, they tell people that they're giving them a vaccine or something, but it's actually vitamins, and because they feel good, they're less likely to get sick. There's a lot of interesting stuff that happens. Okay, so you don't want that to affect the outcome of your study. So people don't know which one they're getting, because they might report that they feel better or something like that. Okay, so is this idea of the two groups, the placebo effect, anything we want to ask about that? I'll pause for a moment, let you think about it. Okay. Does it generally make sense what I mean by the placebo effect in terms of like the effect that it would have on people? Especially if they report, if you're asking them how they feel about stuff. All right. Okay. Let's see. One second, scrolling through my notes about this. Okay, so normally to test effectiveness, what you're going to do is compare results of the control and treatment groups. Okay, that's how we're going to test the effectiveness. Okay, so you're going to look to see, so let's say you have, how many patients? Let's have 451 patients, or 451 subjects in your study. Okay, so you have 451 subjects in your study, and let's see, we're going to have our two groups, the treatment and the control. Sorry. Trying to scroll. So you're going to have your treatment group. You're going to have your control group. Okay, now what are the two outcomes that if you're testing a vaccine, what are the two outcomes you're going to look at to test whether the vaccine was effective? What piece of information do you need to collect at the end? So if you're testing a vaccine, what are the outcomes you're looking for? Right, so what is the intended effect? Like, what should the vaccine do? Or what happened? Well, it doesn't treat a disease. Like, how do you know if a vaccine actually worked? Like, what's the word we use for that? Like cough medicine works if the cough goes away. How do you know if the vaccine worked? Yeah, exactly. So people will either test positive for the virus or get sick. Or they'll test negative for the virus, right? They won't get sick. Okay. Okay, so we had 451 people. So what would happen is you'd have to split them. You'd have to split the 451 people to the two groups. So I'm going to write total over here. So, let's say that in the treatment group, or sorry, let's say that in the treatment group, 33 people got sick. And 191 people did not get sick. Sorry, my dog's going crazy. So in total, how many people did you have in the treatment group? Let me get a calculator. So 33 plus 191 is 224. Okay, so you had 224 people in the treatment group. They got the vaccine. Of those 224 people, 33 of them got sick. Okay. And let's say in the control group, the people who got the placebo. These people got the placebo, these people got the vaccine. 13 of them got sick, and 214 of them did not get sick. So, would it be correct for me to say, oh my god, 33 people got sick and they got who had the vaccine, 13 people who did not get the vaccine got sick. This number is lower, so the vaccine didn't work. Does it make sense to do that comparison? Can I just compare the 13 and the 33? Oh, burrito. My dog, he's so angry. Can I just compare the 33 and the... Okay, why not? Why do we... Why can't we just compare the 33 and the 13 and be like, oh my god, more people in that group? Exactly. Yeah. Yeah, so you can't just compare the numbers. And this is, at the beginning of the class, I talked about how you have to know what the numbers mean and which numbers to use. Okay, so you have to be aware of the fact that you can't just compare the numbers, you need to compare the percentages of the people in the group. So, let's see, how many people did we have in the control group? We had 13 plus 214, 227. So the number that you're actually going to compare, it's called, we want the percentage, we usually call it a proportion. So we want the proportion of people who got sick in the treatment group. That's what P-treatment means. So we want to know if 33 people got sick out of 224, what percentage or proportion is that? So if we do 33 over 224, that's approximately 14.7%. Okay. Now you want to compare that with P control. That's the proportion of people in the control group who got sick. That's 13 out of 227. Let's go and calculate that. Which is, oh my gosh, 5.7%. Okay, in this case, it looks like the vaccine didn't work because a higher percentage of people got sick even with the vaccine. So I would say, looking at these numbers, it looks like the vaccine was not effective. It actually made things worse somehow. This actually happens, oddly enough. Okay. So these two numbers, the numbers that you're looking at, that you're actually comparing, we have a special name for these. They're called summary statistics. Because what they do is they actually summarize the information we had. The information is the numbers like the 33, the 13, the 191, the 214, because that's telling us how many people in which groups got sick or didn't. The summary statistics take those numbers and they summarize it into a single number that you can then compare between the groups. So these numbers are called summary statistics. They take the more complex information and they simplify it. Okay. So a lot of statistics involves like trying to figure out like what's the appropriate information that you can compare. So you'll have the computer usually do a calculation like this for you. So I'll show you eventually how to like take information and have the Wolfram calculate these numbers for you, and then you would have to explain what the result was. Okay. So I'm going to pause for a moment. Any questions about the table, how it calculated the numbers, what they mean? Stop. Just grab my dog. I want to just give you an opportunity to ask questions or finish writing. The program will do that for you. So for now, I'm just sort of like I'm not using the program just so you can get an idea of like the basics. And when we get into actually doing this, the Wolfram will do it for you. Does that make sense? Cool. Okay, so anything we want to ask? Okay. So let's actually start talking about the data. Okay, so we're gonna like break this down. Like, how does this actually work for us? That's the end. What time do we go till? This goes until 2:15. Oh, good. 2:15. Oh, this is a good time to take a break then. Let's take a 10-minute break. It's 1:37. Let's break until 1:50 or 1:47. Okay, so let's break until 1:47. So please return at 1:47. Oh my god, so much noise, people. Jeez. You're killing me. It splatters everywhere. Don't ever put where is it? You don't ever put this in the washer.
What? Oh, why?
Because it can break it. Excuse me. mine, but you
Yeah,
held the
that's
cheese
what
over
we're
here.
going. Yeah, now it's gone, Dad. So yours is the only one that's left.
Oh my god, Mario. Okay, come on, Mario. Okay, burrito, come on, go. Burrito. Come on, go. Burrito. Burrito, come here. Burrito.
I'll pull the trigger on. Someone will put it on the cockpit. But I'll watch it. So that watch. Swing by. Swing by. Washington on the Oh my god, I think that was me. Hold on. I'm getting it. Get it. Burrito? Oh my god. There's some skin high, some skin high. Dad, are you okay?
Oh, this is really bothering me.
Burrito fries?
Everyone's voice. Burrito especially.
Do you want me to take them out on the walk?
That would be nice.
Yeah, I'm gonna go to Dan's. I'll take them with me.
Okay, I'm back. Okay, let's just. Are people returned? Can I see some reactions so I can know if I should start or not? Okay, we got one person. Okay, I count the people. Okay, cool. People know the fuck they're back. Awesome. Okay, so let me switch back to writing mode. And keep going forward with this. Okay, where did my other screen go? Oh, okay. So we're going to talk about how the information works in Wolfram now. So I'm going to share that screen. Actually, no. Yeah, no, we'll write it on here first. Okay, so we're going to talk about what does the data or information look like? And what are the words to describe it? Okay. So when we're looking at the data in Wolfram, or really any program that's made for statistical analysis, you're going to have a view that looks sort of like this. There's going to be a line or some sort of line to tell you that above this line are the names of the information. So let's say that one piece of information you have is called loan amount. Put a vertical line going down. So it looks sort of like an Excel spreadsheet. Let's say another piece of information you have is the interest rate. So obviously it looks like we have information about loans that people are getting. Okay, and let's say another one is the total, or let's say it's the term. That's how long the loan will be for. And final piece of information, let's say that it's type. Okay, so these columns are called variables. And the first line is usually reserved for the names of the variables. Okay, so we have a variable called loan amount, a variable called interest rate, a variable called term, a variable called type. So what you're going to see is a bunch of informations beneath loan amount, and that will be different amounts for loans. So 7,500 or 25,000 or 14,500 or let's put 3,000. And then the ... means that there's more. Okay, so each of these numbers is called a value. So the value 7,500 is a value for the variable loan amount. Okay, the different loan amounts are the values. Okay, let's go over to the interest rate, maybe 7.34. That's the percentage. So an interest rate at 7.34% or 9.43 or 6.08 or I don't know 7.96. And let's put ... for more of them afterwards. Okay, those are the values. The term could be, had the length of the loan, it could be 36 months, maybe 60 months, 36 months, 36 months, and then ... because there's more of them. Finally, the type, so we could put auto. This is an auto loan. Maybe this could be a rental loan. Maybe this is a personal loan. Maybe this is a personal loan. Okay, so these are the values. All these things in blue here are the values. Okay, and we separate the variables so they're put in columns. So when you look at the columns, they're variables. So you could look at all of the loan amount variables, or so you could look at the variable loan amount and look at all the different values. Okay, so the columns are the variables. Now the rows, those refer to individuals. So you need to look at all of these numbers together. All of this tells you about one particular loan, which we'll call the subject. So the rows are subjects. So this loan was for $7,500. It was at an interest rate of 7.34%, a term of 36 months, and it was for an auto. It was an auto loan. Likewise, you could look at this one. It was for $3,000, an interest rate of 7.96%, a term of 36 months, and it was a personal loan. Okay, so there's two ways to look at the data. You could look at it by rows, and that's like about a particular person or subject, or you can look at it by columns. That will just tell you about a particular type of information. So if you look at the columns, you could just look at the loan amounts or the type of loans. Okay, but that doesn't tell you about a specific individual. Okay. Is that making sense so far? The two different ways you can look at this information? Any questions about it? Okay. This whole thing is called a data frame or data matrix. The data frame or matrix is where we keep all of the information. Okay, so all of this is where we store all the information. One second, I have to get something off of my stove. Okay, so when you look at all of the variables together like this, we call it a data frame or a data matrix. Okay, you have the names of the variables on top, and then you have the values. Okay, so it's very important to distinguish between those two. Okay, so we've got that so far. So now we're going to talk about the different types of variables that we have. So there are two primary different types of variables. There are numerical variables and then there are categorical variables. Okay. So what do you think makes something a numerical variable? Like given the name. It's a yeah. So you can basically figure out what sort of variable you're working with by looking at the values. So to figure out which type, look at the values. Okay. Generally, if it involves numbers, it's probably going to be numerical. Okay. So this will involve numbers. So actually, it involves numbers which have a meaning. Involves numbers which have a particular type of meaning. And those numbers need to either count or measure something. So if we go back up here and look at this, let's look at the variable term. So the 36, what does the 36, does the 36 have a meaning? Yeah, does it have a meaning? In the sense that I talked about earlier, that a numerical variable has a meaning. When I talk about the term of a loan, what am I referring to? How long it is. So 36 months, does that 36 count or measure something? So if we're talking about that number 36 and we're talking about the length of a loan, does it count or measure something? Yes or no? Oh, people, are we here? Am I speaking into the void? Sometimes I wonder. It measures time, yeah. Okay, cool. So, yes, that is a numerical variable. But what if we had a variable like, you know how you can have a number on your jersey? think I'm spelling Jersey right. Let's say the Jersey numbers are 1, 10, 58, and 66. Is this a numerical variable? If I'm talking about like if you're looking at people on a basketball team or something like that, you know, they have the number on the back of the jersey. Does that number count or measure something? No, it's not like if someone has the number 1 on their jersey that they have 1 of something or it measures 1 of something. So just because you see numbers doesn't mean, it doesn't necessarily represent or mean something. So you have to be very careful. Just because you see numbers doesn't mean that it's a numerical variable. Okay. So let's talk about categorical variables. So if numerical variables deal with numbers, what do you think categorical variables deal with? Any guesses? A type, and it will usually involve words. So a categorical variable places something into a category. It places a subject into a category or type. Usually that category or type will involve letters. So if you look at this type variable, do you see how there's different types of loans? You can have an auto loan, a rental loan, a personal loan. This is an example of a categorical variable. Okay. Now, for each of these types of variables, numerical and categorical, they're further split into more specific types. So let's talk about numerical variables first. So there's 2 types of numerical variables. There are discrete numerical variables, and then there are continuous numerical variables. Continuous. Okay. You are a discrete numerical variable if the number counts something. You are a continuous numerical variable if the number represents something which is measured. Usually you can tell which one is which. Sometimes it could possibly be either. So if you're counting, what are you never going to have in terms of the numbers that you see? It's a good question. So if your variable is a discrete variable, it counts stuff, what sort of numbers will you never see? You're never going to see fractions or decimals. No decimals / fractions. There's only going to be whole values. Why? Because is it possible to count half of something? No, it's either 1 or there's 2 of them. There's no 1 1/2. You can actually have decimals for the continuous variables. So let's look at some examples of this. Let me find one. Oh my gosh. Sorry, I'm trying. Oops. I'm like scrolling on the wrong window. I apologize. Oh my gosh. Let me come up with one. Let's say, or how about this? Can someone come up with an example of, actually, so sorry, let me scroll up here a little. So you have variables like loan amount, interest rate, right? See how there's different loan amounts, there's different interest rates. What's a piece of information that you can track that would be a discrete numerical variable? In other words, it's a piece of information that counts something. It's like, what would be an example of a discrete numerical variable? Something that you can count. Just throw out some examples. What do we come up with? What's something that you can count on people or count in the world? Age, what else? What was the other one? I heard another one. I heard age, and then someone else said something. What was the second one? Give me some more. Number of people in a room. There we go. Age, number of people. How about this? Number of siblings. I can go and I can ask everybody, how many siblings do you have? Right? No one's going to say 1.7. It's either you have one sibling or you have two siblings. It's not like you can give a fractional amount if they're dead or something. Yeah, population. You either have a whole number of people. Okay, any others that we can think of? Oh, work history in years. Like, yeah, number of years worked. Number of years at a job. Okay, cool. So there's a lot of different things. You can count a lot of different stuff. All of these would be examples of discrete numerical variables. Okay, now, continuous numerical variables, they're things which are measured. So usually for this, you have things like height, weight are good examples, right? Those are measured. You can't count how tall someone is, you measure it. Can anyone come up with some other interesting ones other than like height and weight, things which would be measured? Yeah. Most sports stats are things that are measured. Because usually you end up getting... amount of force, that's a good one. Speed, yeah. The person pointed out that speed is like distance over time. Things which are ratios are usually continuous, because you've got a decimal. Length is a good one, amount of force. Yeah, so things in the physical world are usually measured. Those will normally end up being continuous numerical variables. Okay. So is this sort of making sense how you would see the difference between, figure out which group it would fall in? You would look at whether would I measure this or would I count it? Okay. Anything we want to ask about the difference between the two? Okay, so let's talk about the other types of variables. So let's talk about the two types of categorical variables. So remember, categorical variables place things into categories. Okay, so there are two types of categorical variables. There are nominal categorical variables, and then there are ordinal categorical variables. Okay, something is a nominal categorical variable if there is no preference or order to the groups. You can think of like a hierarchy. If there's no hierarchy of the groups, it's nominal. An ordinal categorical variable is when there is a hierarchy of the groups. So let me give you an example of an ordinal categorical variable. If you look at grade that you can get in a course. So like, what are different examples of grades you can get? You can get A, you can get B, you can get C, D, F, you can you can get a withdrawal, you can get a no credit, and an incomplete. So those are the values for that variable. Would everyone agree that there is a order or a preference to which grade you would want? In other words, some of the values are more important than the other. Like we would think that an A is better than a B is better than a C is better than D, a D is better than F, and maybe an F is better than a withdrawal. It's also probably better than no credit. It's also probably better than an incomplete. Okay, but there is an obvious order to the values of the variable. Okay, that's different from, let's say, my variable could be, what's your favorite ice cream? Okay, someone can say that their favorite ice cream is pistachio. Or someone could say that their favorite ice cream is ube. Or someone could say that their favorite ice cream is mango. Is there a generally accepted reason to say that liking pistachio is better than liking mango? Hopefully not. Okay, so that would be a nominal categorical variable. Okay, so questions about the difference between the two, where we're sort of seeing the distinction between the ordinal variable and the nominal variable. I'll pause for a moment. Oh my gosh, just gray screens. Are you there? React if you're there. I feel so alone. Oh. Okay, cool. Okay, people are listening. So it just makes complete sense, or no questions, or writing? Oh, okay, cool. I understand. It's fine. That's nominal because there is no preference to which ice cream is better than the other, unlike like grades where you could say that an A is better than a B, which is better than a C. So if there's an order or preference, it's ordinal. If there isn't, you would just say that it's nominal. So favorite ice cream is the example of a nominal categorical variable. Grade would be an ordinal categorical variable. Because hopefully you think an A is better than a B, and so on. Do I go too fast? Should I slow down? How do we feel on the speed of my lecturing? Okay, cool. Okay, good. I just always worry, like sometimes it's like an odd thing doing this. It's like doing a really bad live stream. Like I just don't know if people like aren't paying attention anymore. Like you just like showed up, you run it, and you're like go away from keyboard, or if you're writing or what. So I always try to like ask questions so people can be involved. But then yeah, sometimes it's hard to know if you're just like writing because I can't see what you're doing. Sometimes it feels like talking into the void. Interesting thing, I'm also live streaming this. Oh, thank you for turning on your camera. I'm also live streaming this on YouTube. Thank you. Yeah, there's a lot so far. There's definitely a lot to cover. And I think actually, what time do we end? Are we supposed to be ending like right now? Oh, in 4 minutes? Okay, cool. We have a little bit to talk about. Okay, cool. So, let me do some examples of like some sort of weird ones. To see if you can come up with this. So let's say that you have your variable is zip code. So you could have like 95232 or 94896 or 90032 or 90650 or I don't know 111004. What sort of variable do you think this would be? So you always want to start at the highest level. So you have to ask yourself, is this numerical or is it categorical? So why are you going to categorical? Like why not numerical is what I'm going to ask you. Like there are numbers, why isn't it numerical? Yes, exactly. The zip code places you in a category of people who live in a particular area. You use the word identifier, but we'll say category, as opposed to the number counting or measuring something. So remember earlier I said for it to be a numerical variable, the number needs to count or measure something. So these 95232 does not mean 95,232 of something, nor does it measure something which has 95,232 of whatever unit. It does not count or measure. So it's not numerical. Which means it has to be categorical. Okay, so now that you know it's categorical, now what do you have to figure out? And I'll pause a moment because I know people are writing that down. What's the other one? Nominal or ordinal. Good, right. So you have to figure out, is it nominal or ordinal? So how do you distinguish between whether it's nominal or ordinal? Like, what are you looking for? Yeah, there is an order to it. Like, as you move, does anyone know where the zip codes start? Does anyone know where the first zip code is? Like 1000000? Yeah, I mean, there's all the zip codes. It starts in New York, and then it wiggles its way across the country. You start at 0 on the East Coast, and that's why we're at 9 on the West Coast, because, the country was started on the East Coast. So it starts over there, and it works its way up to the highest number on the East Coast. So you could say that it's ordinal, because there's an order, and in particular, a geographical order to all of this. Yeah, I mean, that's what a zip code is. You look at the whole point was it was created so that when the post office was looking at your letters, they would look at the zip code to figure out generally like where it should go. Like if the person saw a zip code that was nearby, they'd put it into a pile for local mail. If they saw a zip code that was far away, they'd put it into a thing of like, oh, this needs to go on a plane and sent somewhere far away. Then they'll figure out where it goes after that. Zip stands for speedy, so the zip code. So yeah, this would be you could say that it's probably an ordinal categorical variable, because there definitely is some sort of order to the zip codes. This one comes after that one, comes after that one. Yes, yeah, it totally depends upon the context of where you're looking at the number. My bad, sorry, I burped. So yeah, the context matters a lot. If you don't know the context, I wouldn't stress out too much about it, and you could just give your reasons for, given what I know, this is what I think. But it's important for you to say, like, I think there's an order to it or not, to give a reason to explain why you think that about the variable. So yeah, providing context is key. Okay, we're going to end there. And good. We have covered most of Chapter 1, Section 2. We'll pick that up next class. Okay, so I'm going to end the recording. And I'll stick around to answer any questions you might have.